Hello and welcome to tutorial on how to draw critical path network diagram. In this tutorial, we will take three scenarios. Scenario 1, when you have successor information given. Scenario 2, when you have predecessor information given. And scenario 3, when you have node information given. Three scenarios. Now, before we get into drawing the critical path network diagram, let's understand one thing, which we have already covered in the lectures. These are two methods of drawing critical path network diagram. One is activities on arrow method, and second is activities on node method. So what is activities on arrow method? Activities on arrow method is when you draw the activities on arrow, and activities on node method is when you draw activities on node. As we know that activity on arrow method is a old method, where activities on node method is a relatively newer method, and all the softwares like Primavera and Microsoft Project uses activity on node method. There is one difference between activity on arrow method and activity on node method is that in activity on node method we don't have any dummy activities, where in activities are arrow method, activities on arrow method, we may have dummy activities depending on the type of relationship the activities has. Therefore, activity on node method makes the solving and drawing the network diagram easier. So I always recommend that whenever you have problem given in the examination, you use activity on node method. However, when you have been given node information in the problem, this means that you have to draw only activities on arrow. We'll understand that once we solve the problem. What do I mean to say when the node information are given? Then you can draw only activities on arrow method. So let's start with our first scenario. Scenario 1, when successor information are given. So let's see what we have. Here on the table, we have activity A to activity G, and we have all the successor information given here. Now when we draw a network diagram in any method, maybe when you have successor information given, or you have predecessor information given, both ways, what we have to do first, we have to identify which is a starting activity and which is the end activity. So how to identify the start activity of the network diagram? When a start activity is the activity which do not have any predecessor. So what is the mean of that? In the list here, you will not see those activities. The first activity in the successor information you will not find in the list. So if you see carefully, we have A, B, C, D, E, F and G. However, A is missing. So what is the meaning of it? A is a first activity. So let's write down A as a first activity. Now what is the last activity? Last activity will be the activity which will not have any successor. So here G is the activity which is not having any successor. So let's write down G as well. So we have written A and G, first and last activity. This basically identifying first and last activity makes your problem solving a little easier. So it is always recommended that you identify and draw first and last activity at the first step of solving such problem. Now let's go to activity A here. Activity A we have here, activity A, and activity A has three successors, B, C and D here, right? So what we have to do, first we have to draw those successor, draw those nodes. So let's draw those nodes. So we have node here, B, C and D nodes are here now. Now we have to join these nodes using arrow. So what is arrow notation? The successor activity will have the head of the arrow, whereas the predecessor activity will have the tail of the arrow. So let's draw them. So we have here B, C, D arrows drawn, and as you see here, D, for example, is a successor activity. Therefore, the arrow will be towards D, and the head of the arrow will be towards D, and the tail of arrow is towards A. So this is how the notation works. Quite easy to understand. I mean, this is a predecessor activity. We have to finish it and then go to activity B, which is successor activity. Therefore, the arrow will be in this direction. Now let's go to activity B now here. Activity B here. Activity B has two successor. They are E and F here. So let's write down those E and F here. So we draw the activities E and F now. And then arrow notation is as we discussed before, that will be from B to E and B to F. So let's draw them now. So let's draw them then again. So here I draw them, and then we have all the node information again. Node and arrow information we have put in, right? Now let's go to activity C here. We have activity C here, and activity C. Activity C has only one successor, that is F. So let's link it. So C and F, we draw that. Now we go to activity D now here. Activity D is here. Now we have activity D here, and activity D has only one successor, that is G here. So that is G here. So let's draw that G here. So let's put the arrow. An arrow will be like this from from D to G. Now let's go to activity E now here. Activity E has only one successor, that is again G. So we have to draw from E to G. So let's draw it. Now let's go to activity F here. Activity F has two successor, E and G. So let's link them together. So F has E, so it will go in this direction, and G in this direction. So this is how our network diagram will be finished when we have all the successor information. We can check them, and we can check from beginning to end. Activity A has three successor, B, C, and D. Then we have activity B. Activity B has two successor, E and F here. Then activity C has only one successor, that is F. And then activity D has one successor only, that is G, that is mentioned here. Then activity E has one successor, that is G. And then activity F has two successors, they are E and G is the last activity, and it does not have any successor. So this is how the network diagram is complete now. Now we have second scenario where we have predecessor informations are given. So let's see what we have here. We have again activity list from activity A to G, and then we have a predecessor information for respective activities. Basically, this is the same network diagram what we drew last time. This is only, the change is only that previously we have been given successor information. Now we have predecessor information. So how to start with? Again, the first step is to identify first activity and last activity, and that's what we are going to do. So it's quite, in the first activity identification is quite easy, as we talked in the earlier problem, that the first activity will be the activity which will not have any predecessor. So it's quite easy, right? A is the activity without any predecessor here. So there's no predecessor for A. So A is the activity, right? So A is the activity, and then let's draw A now here. So we'll see A here. Now A is the first activity, and then we go and see which is the last activity. Again, there is just a change here from the last problem. Last activity will be the activity which will have no successor, means that will not be found out in the predecessor list. So if you see here, we have A, we have B, we have C, we have D, we have E, and we have F, but the G is the activity which is missing. So let's put G here. Therefore, G is the last activity. So we draw G here. and then we have the first and last activity drawn. Exam also you have to find the same way to solve the problem. Identify first activity before and then put the last activity. Then let's go and talk about activity by activity. So activity B is the first information we have. The B has got A as a predecessor. So we'll draw B here, and B is drawn here. And what is the predecessor? A. So what will be the arrow direction? Arrow direction will be that the tail of the arrow will be towards the predecessor activity and head of the arrow will be towards successor activity. So we draw it here now. Okay. Now let's go to activity number C. Activity name C. C has one predecessor, that is A. So let's draw it here C and let's put the arrow A. And then we go to activity D here. Activity D, same thing. Activity D has only one predecessor, that is A. So let's draw A here. Let's draw D here. And then let's put the arrow here. Then let's go to activity E here. Activity E has two predecessors, that is B and F. So let's draw activity E first. So we have activity E here now, and then we have two predecessors of B and F. B is already existing, so we'll draw only a relationship with B, and we will wait when we will in the relationship linking between E and F, we'll wait until we find activity F drawn. So we are going to draw it now. So we have activity F now here. Activity F has two information B and C. So let's draw activity B here, which is, let's draw activity F here, and activity F has two predecessor B and C. So let's draw the relationship one by one. So we draw it. And last relationship what we have is activity G has three predecessors, that is E, F and D. So all the predecessors are already drawn here. So let's put the relationship. So here we have relationship first of relationship between E and F, we draw it, which was left before, and then we draw the relationship of E, F and D. So let's E, and then we have F, and then we have from D. So this is how we draw the whole network diagram when you have a predecessor information given, right? Just the reverse of when we have the successor information given. We can check that, quite simple to check it. It's a good idea to always check or randomly check. Let's say activity E here. So what is the relationship activity E has from B and F? So let's talk about activity E has two predecessors B and F. So let's see. The important thing is to check arrow directions, because these arrow direction will determine the way we are going to do the forward pass and backward pass in order to determine the critical path method. So the arrow directions are important. So we should either, the good idea is to either check whole, because we checked in the last problem. So I'm not going to check for all of them, but I'm randomly checking with activity E and finding that B and F are the predecessor to activity E and the arrow directions are right. Okay. So with this, we complete the scenario 2 when we have a predecessor information given. Now we have scenario 3 when node information are given. So let's see the table here. We have activities here from activity A to H. This is a different problem from what we have before. And then we have node 0 to node 5 here. Okay. Now let's start solving this problem. Now there's a little difference between the problem what we have before, where we have predecessor and successor information given. So what is difference? The difference is that those two sets of scenarios we can draw using activities on node method. However, when you have a node information given, you have, in order to solve the problem, the best choice is to draw using activities on arrow method. Okay, so we discussed the difference between two. Activities on arrow method is a critical path diagramming method where we put the activities on the arrow. When activities on a node method, we put activities on the node. So in a given scenario, we are using activities on arrow method, and we will have to draw the nodes and connect them with arrows, and each arrow will represent our activity. So let's start doing that. Similar to the approach what we found in the earlier two scenario, we have to identify first, which is a starting node, and second, which is the last node. And it's quite easier here. The first node will be the least number, which is 0, and the last node will be the highest number, which is 5. Why? Because activities in activities and arrow methods are represented by the node numbering. So the first activity will be the node, the least numbered node will be the start of the first activity. We'll understand that. So first identify the first node, which is 0 here, 0, and the last node is 5. So let's draw it. So we have 0 here, which is the first node, and the last node is what? The last node is 5. So let's draw it here on. So we have 0 and 5. Then let's go to activity table and see here we have activity A here, and activity A has 0 and 1. Right? The nodes are 0 and 1. So 0 is a starting node and 1 is a finishing node, right? So we have 0 node here, and let's draw node 1. So we have 1, 0 and 1. So 0 is a predecessor node and first 1 is a successor node. So we are going to have an arrow connected like this. So let's draw the arrow, and on the arrow we are going to write the name of activity, that is A. So activity A we have written here. Similarly, let's go to activity B here. Activity B has 0 and 2 nodes. So 0 we already have it here. Let's draw node number 2. So we put node number 2 and join them in the arrow. And then on the arrow we are going to write the activity name, that is B. So we draw A and B. Now let's go to activity number C here. So activity number C is here now, and then we have node 1 and 2 here. So node 1 and node 2 here, and let's draw them. So let's draw 1 and 2. So here goes the activity number C now. Okay. Now let's go to activity number D here. Activity number D we have here, and D has 1 and 4. So let's what we have to draw? We have to draw node number 4, and let's draw node number 4 here, and let's put the activity D here on top of that. Similarly, let's go to activity E. Activity E had 2 and 3, node 2 and 3, and then we draw it here. Then we go to activity F here. So activity F we draw it here now. Activity F is between 2 and 4. So we draw it here 2 and 4 and right here on the top of arrow, because again it is activity on arrow method we are following, so we draw it. Then we go to activity G. Activity G we have, so we that is between node at 3 and 5. Already 3 and 5 had been drawn. So let's join them together. So here we go 3 and 5, and we put on top of that activity name, that is G, our ID, our name. And then we have last activity H, that is between 4 and 5. So this is how we draw the CPM network diagram when we have node information given, and as we understood that we have followed the activities on arrow method here. Now in the same concept you will see that there can be concept of dummy activities. If there is a relationship between, say the activity after activity B has finish to start relationship with say activity activity like activity H, so activity B has finished to start activity with H, and then what we are going to do here, we are going to have a dummy relationship between activity B and H by using a dummy activity here. So we can draw a dummy activity and then we can add it here, and then that dummy activity will give you a finish to start relationship here, and this is how the concept of dummy activity will work. But there is no physical work here because that is not an activity, only it's a relationship between activity B and activity H. So that is how the concept of dummy relationship comes into the picture. With this, we complete this tutorial on drawing the critical path network diagram. In the next tutorial, we'll take one critical path network diagram and identify the critical path by doing the forward pass and backward pass.